Hey everybody, so we're going to be talking about congruent chords and arcs. You do have a large figure up front, and we're going to be using the three theorems, and those three theorems are going to be using this figure right here. So if you want, you can color code it. I'm using 3 different colors. I'll also show you on the screen individually what they look like. All right, so the first one that we're going to do is that 2 chords are congruent if and only if 2 corresponding arcs are congruent. So what that means is that if we're on this circle right here, okay, that AB and CD, these 2 line segments, are congruent if and only if arc AB is congruent to arc CD. So right here, you've got arc AB and line AB right there, line CD and arc CD. So if those 2 parts are congruent to each other, and I know it's kind of huge right there, so let's do. Here we go. So if these 2 are congruent to each other, then AB and CD are congruent to each other. And now the reverse can also hold true. So that if AB and CD are congruent to each other, then their arcs are congruent to each other. It's kind of like when we were working with triangles and the angles and we were pointing at them, if that brings back any memories. All right. So we are going to go ahead and practice this one here. And we're going to solve for x. So I want you to notice that they've told us that these 2 chords right here, SR and ST, are congruent. Okay? Therefore, 7x plus 24, okay, that arc SR and arc, ST is also congruent. So both have to be true. If one is there, the other one will also happen. The other one cannot happen without. So we can then set up our equation and do 115 is equal to 7x plus 24. And we're using substitution and also our equivalency properties to do this. And then we just solve for x. Move the 24 over, you get 91 is equal to 7x. And then you're going to end up getting, and I'm going to swap it out, and it's going to be x equals 13. And that's how easy that was. So you're going to do the same thing here, but it's a little bit different slightly. All right, now that you've kind of gotten a chance to look at it, you'll see that ZY is congruent to XY. Which means arc ZY is going to be congruent to XY. But they haven't told us anything besides, they haven't even told us this length right here. And all we have is to solve for x. But what you can do is realize that these 2 are congruent, meaning this is also 6x minus 20. And then remember, an entire circle is 360 degrees. So you're going to get 2 times 6x minus 20 plus 76 equals 360. And then distribute, combine your like terms, move your letter variable, add, subtract, multiply, and divide to solve for x. If you need a pause before I write the answer, do it. And you should get that x is equal to 27. And that's because I got 12x minus 40 plus 76 equals 360. So I have 12x plus 36 equals 360. And then I had 12x equals 324. Divided both sides by 12 and I got 27. All right. This one right here, same thing, and it's going to be that same process. Okay? However, what they're asking you this time is not to solve for x, but instead to find xy. So, let's do it. We know that xy right here is going to be congruent to wv. And the reason we know that is because those chords are congruent. So because wv, arc wv, and arc yx are congruent to each other, then chords or line segments wv and yx, are congruent to each other. And therefore, using the definition of congruence, you can set them equal to each other and solve for x. You're going to solve for x, and then you're going to plug it back into either one of these, since they're congruent, and tell me how much xy is. All right? When you're done, you should get that xy is 29. Okay? So make sure you got x equals correct, and xy equals 29. X was equal to 7. Okay? Now let's talk about the second theorem right here. Two chords are congruent if and only if the two chords are equidistant from the center. So, if we're looking at this, AB is congruent to CD right here. These two. If and only if, meaning one cannot exist without the other, and that's that they are equidistant from each other, meaning these two parts right here, EF and EG, they are also going to be congruent. All right, and before we go to the next one, I'm going to give you the third one, and we're going to do a mega problem where we do all of it together. Actually, I lied. We are going to do this one first. Sorry, it's a little out of order. We're going to do if DE right here is equal to 11x plus 15, and FG is equal to 32x minus 27, cool, find DE. Well, in order for us to do that, we have to notice that they are both equidistant from the center, meaning that since whatever these 2 points are, if we come up with xy, for example, since hx is congruent to hy, then we can also state that DE is congruent to FG, and therefore you can set them equal to each other, which gets us 11x plus 15 equals 32x minus 27. So solve for x, and then find DE. Okay, and in order to help you check your answer, you should get that DE is going to equal 37. Awesome. I hope you've got this down. We are going to now do our third theorem, and that's if a diameter or radius is perpendicular to a chord, just like here. Then it's going to bisect the chord and its arc, meaning that right here, if EH is perpendicular to AB, so I'm going to be working on just that top one, then it's going to create two different things. It's going to say that AF is congruent to BF, right here. And the measure, or I'm sorry, it'll split the measure. But arc AH is going to be congruent to the arc of BH. Now that also works for the angles right there if you need them. And I say that because we've got this mega fantastical problem right here. Okay, if you can do this problem and the last one, then you are set for your assignment. So if GJ, and I'm going to go through it in order, and I'm going to color code it so I can keep up with what's happening. If GJ is equal to JF, so GJ is equal to JF, so those two are congruent, that means. Oops. And that's what that should say. GD equals 13. Cool. And the measure of arc CD is 136. Find each measure. So we're going to do the same thing that we did last time. We're going to ignore this. And we're just going to figure out our circle, given what we know. So what we do know is, because I'm going to start from my yellow, the first thing. Because we've got these two being equidistant, we know that CD is also going to be congruent to EI. And that means that because the line segments are congruent to each other, that guess what? That means it's going to cause a domino effect, and it's going to state that arc CD, is also congruent to arc EI. You see how it's a domino effect? As long as it's equidistant from the center, it causes both of the theorems to happen then. Okay? So that means all of this is also going to be 136. And hey, that means we could figure out what arc CE is, because the entire circle is 360 degrees. So we do 360 minus 136, and you can even double it up to begin with, and do 136 times 2, since you've got two of them, and subtract that from the 360, and that's 272. Subtract the 2, and you get 88 degrees. So now we know that CE is 88 degrees. And had there been a central angle here, then the measure of that central angle, CJE, would be 88 degrees. Okay, so we've got enough from there. But what we also see is that JH is bisecting both CD, the arcs, and the line segments, the chords. And that's because it is perpendicular right here. That means these two are congruent, these two are congruent. And hey, remember, that means these two are congruent too. It also means these are congruent in both the length and its measure, meaning in both degrees and how long it is. All right, and you see how they've told us that GD was 13? Well, guess what? Now we can say that this is 13, and this is 13, and this is 13. Oh, interesting. So if that is 13, that means that entire thing we could figure out would be 26. Fun how that works out, right? Now, we can also use the same property for our angle measures here. Notice how CH and HD, both of those minor arcs, are congruent to each other. So we're just going to do 136 divided by 2, and that's going to give us the arc measure for all of those. And that's going to mean that this is 68 degrees, and this is 68 degrees. And so is this one, and so is this one. So again, if you had a central angle, EJI, then the measure of that would be 68 degrees. And same if you had a central angle, DJI. But you don't have central angles here. All right. So now that we've got all of that, you can fill things in. It's asking us for the measurement of ED. Well, 13 plus 13 gets us 26. CF, we know it's congruent, so it's 13. The measure of arc ED. Notice this is a minor arc, so it's not going all the way around. In fact, it's just asking us for that 136 degrees. Then it's asking us for minor arc HD, which is 68 degrees. And then it's asking us for minor arc CE, which is 88 degrees. And if they asked us for any of the major arcs, well, we would just add them up because we know how that circumference has been split up. All right, final problem. And this one's going to be a little bit more of a doozy because you're going to need to use some trig for it if you need it, or the Pythagorean theorem, whatever helps you. All right, so we need to find VW, and we need to find this chord right here, but we also need to find the measure of arc YW. Okay, so I'm going to do this one first. It's just easier. Okay, so VW, you know what we have been given? We could figure out what ZW is because you've got this right triangle here. You've got a 5 and a 13, and you need to find this leg. By the way, if you know your Pythagorean triple, you won't have to do any math because a 5, 12, 13 means that this leg would be 12. Now, if you're like, wait, how did you do that? Or you don't remember your Pythagorean triples, then just do a squared plus b squared equals c squared and solve for it. And you would get 5 squared plus whatever b squared is equal to 13 squared. So you get 25, 169. And do all of this math and then do 169 minus 25 is going to equal b squared. And that's going to give you 144 is equal to b squared. But you need to take the square root, and you get 12 is equal to b. That's a lot of work when all you have to do was just remember that a 5, 12, 13 triple. That's it. And if ZW right there is 12, we know that VZ is also going to be 12 because of this right angle. It's being bisected. That means all of VW is going to be 12 plus 12, which is just 24. And it's really that easy if you just remember your Pythagorean triples. They will help you for the rest of your math career. All right, the next one says we have to find the measure of arc YW. Well, we've got a central angle there, and it's going to be congruent to YXW. That means I need to find out this angle right here. Well, how do we find the measure of an angle if we've got its side lengths? If you don't remember, I'll tell you. Kind of sounds like staccato. Yeah, that's right. You're going to have to do so, ka, toa. And we have to figure out which one we're working with. So we're going to use, and it doesn't matter which one you use. This was the one that we found. So I like to use both of the ones that they gave us. So that means if we're working with our right triangle, 5 and 13, this is my adjacent, and this is my hypotenuse since it's across from the right angle right there. So we've got cosine of whatever that angle is, we'll say x, is equal to 5 over 13. Well, I need to find the angle, so I'm going to do cosine inverse of 5 over 13, and that's going to tell me what x is in degrees. So let's go ahead and pull up our calculator. Now remember, you must be in degrees mode. So we're going to go to mode, change it to degree, and then we can do cosine inverse. So second cosine, of 5 over 13. And you can just type it in like that. If you want to do it as alpha y equals, it'll give you the same exact thing. And we get that x is going to be approximately 67.38 degrees. Typically, I'll tell you what to round to. So if I tell you to round to the nearest degree, your answer would have been 67. If I told you to round to the nearest tenth, it would be 67.4. If I told you to round to the nearest hundredth, which is what I've done, is 67.38. All right, thanks for watching.